Okay. Do you manage to go back and try out this part? This one. Okay, so let's check our answers, okay? So in this case, right, we have x intersect y complement, then complement again. Okay? So that means that x itself, okay, if we look at x itself, the circle, intersect with y complement. Okay? That will mean that anything that's outside of y, okay, intersecting with the circle x. So that means that we are looking at, let me just use a pencil to roughly shade first. Okay, we are looking at this portion, okay, for x intersect y complement. But because we complement it again, that means that we want things that are not this shading. Okay, so therefore, the shading that we should be getting will be anything that is outside my pencil shading. Okay, I hope that we're getting the answer over here. Right? Anyone need me to repeat? Yeah. Okay, so now I want us to be able to draw some conclusions, okay, out of the Venn diagrams that we have shaded so far. Okay, so from the answer above, the question first asks, is x union y complement equal to x complement union y complement or x complement intersect y complement? That's a mouthful to say. Okay, so let's find out where is this x union y complement first. Okay, it is actually this part 3 over here. Okay, so the question is asking whether is this actually equal to this one or actually is it equals to this one. Okay, so from the shading itself we see that these two are actually equal. Okay, so what does this tell us? Okay, we'll go through all the questions first, then we draw a conclusion, right? So it's actually equal to x complement intersect y complement. Okay, so this and this are equal. Just let me write a complete statement. Okay, then for question 2, sorry, this one is back nothing inside, is it? It's empty. You don't need to go and throw it away. Just move it aside, I'm blocking my view. Okay. Then question 2, we are asking whether x intersect y complement, bracket complement, okay, which refers to this one over here. Is it equal to x intersect y, x complement union y, or, okay, maybe I jump the word complement, change it to prime, okay, they mean the same thing. X prime intersect y. Okay, so question is asking whether this one over here, is it equals to this first one, or is it equals to this one? So clearly, by matching this and this, we see that they are equal. Okay, so we can conclude that this equals to this one, and they are equal. So we're trying to pair things up in this case, yeah? Okay, and then finally, okay, the question lastly is asking x intersect y bracket complement, right? Okay, which is actually not shown in the diagrams over here. Is it going to be equals to x prime intersect y prime? That is this one. Or is it equals to x prime union y prime? Okay, so we can try to think about how does this actually look like. Okay, if you want to. Right? But actually, do we really need to draw out the Venn diagram itself or shade the Venn diagram? Okay, so let's look at question 1 and question 2. Okay, what is the conclusion that we're getting? We notice that, sorry, this is the focus, this. Okay, so we notice that we have x So let's think about it like algebra. Okay, what happens when you have brackets and a negative sign outside? So we think of the complement like the negative sign. Okay, so we draw an example. Okay, so when there's a negative sign outside for our usual algebra, right, we will bring it in, correct? Okay, if this one were, let's say, to be a minus, the minus sign outside will cause this operation to become a plus, because minus and minus will become plus. Correct? That's what we know about algebra, right? You all follow what I'm saying? Okay, so if it's talking about algebra like this, we know that I can bring in the negative sign, and then I will be able to get negative a plus b in this case. So it affects and changes operation over here. Not only that, it also actually changes the a to become a negative a. Originally it's positive a. So with that kind of idea, we draw a similarity to our set notation in this case. Okay, with the complement sign on the outside and the brackets, when I remove the brackets, what is the effect of the complement sign to the things inside? We notice that x becomes a x complement. Follow me? Okay, then after that the y becomes a y complement. Okay, then what happens to the union? The union sign becomes a intersection. Becomes the opposite. Okay, so do you see that parallel towards your algebraic idea? Okay, then we check again. Okay, the second question. Okay, we have over here, let me just draw it darker. Okay, we have x intercept y prime bracket complement. Okay, the prime over here, bring it in, what happens? X becomes the x prime. Okay, y prime is a double negation, okay, double negative. Negative, negative become positive, so it becomes a y itself. Okay, and then the intersection becomes a union. Okay, so do you see that now? So with these two examples, we notice that when there is a set of brackets and the complement sign on the outside, we can so-called bring the effect into it, into the things inside, by changing everything into the opposite. Okay, so therefore, in question 3, right, when asked about x intercept y bracket complement, which one is it going to be equals to? We apply this algebraic idea to it. Okay, so it's going to be x complement union y. Okay, so x complement union y. So therefore, yeah, type wrongly. Okay, sorry, union y complement. Yeah, my bad. Okay, so x complement union y complement. Okay, so therefore the answer will be this one here. Okay, so if you, even if you don't believe me, we can always do a check. Okay, draw out the Venn diagram. So for x prime union y prime, right? Okay, this one itself is already in part 4. Okay, so this one is the answer in part 4 already. Let me just tidy things up on the board. Okay, so this one over here is already this one. What if I want to shade something like that? Okay, so let's draw a similar Venn diagram. We should be expecting to get the same shading. Okay. Okay. So this is x, this is y, this is your universal set. So x intercept y refers to the center over here. We want the complement of it, that means anything that is not the intersection, which explains that it is going to be this shading over here. Right? So based on how we understand how to shade this one, we should be getting this. Okay, and this shading is exactly the same as this one. Okay. So therefore, we draw the conclusion about how the bracket and the complement sign, how we can simplify the notation into this one. Okay, questions? Okay, so with that, right, okay, the shading part, okay, I want you to do the exercise 1D question 9 as homework, okay, likewise, question 10 and question 11. Okay, this is a very fun activity, although it can be tedious, right? Go and try it out, go and practice it. All the different kind of possibilities that your Venn diagram could look like. The overlapping kind, okay, and then the ones that are actually subsets of each other, and also the disjoint one, okay? So, with this conclusion over here, right, okay, what we can learn from this is that, okay, if we are given brackets, sometimes it might be easier if we simplify it, okay, to remove the brackets. Okay, sometimes it might actually be that way, right? Okay, otherwise, what you could also do, sometimes with a lot of complement, you can adopt a factorization idea as well. Okay, so what we have done here is that we adopt an expansion idea, okay, loosely put it, okay. But then if you have things like that, okay, x complement intersect y complement, okay, you can adopt a factorization idea as well, where you're factorizing out the negative, factorizing out the complement sign. Okay, so how would that work in this case? Okay, if I want to factorize out the complement sign, that means that the x complement must change to x. Intersect must go into the opposite union. Y complement take out the prime must become a y. Okay, so it is a adoption of the algebraic expansion and factorization ideas. Okay. So sometimes it might actually be easier to interpret this way rather than it's in raw form. Okay, so go ahead and try out the 3 questions, okay, for homework. Now I want us to get back to our notebook and our textbook. Turn this off first. Now 7. Question 1. So far? Right, let's look at practice now 7. We are given these 3 sets over here. We have the universal set and then set A and set B. Okay, let's very quickly list out all the elements in the universal set. Let's pick one person. Chloe Yo. Where is Chloe Yo? Okay, yes, Chloe. Okay, tell me what are the elements in the universal set? Until 9, okay. Okay, question says not more than 9 means that it is less than or equals to 9. Okay, and we want positive integer, therefore 0 doesn't count. So we start from 1 all the way to 9. Okay, and what would the elements in A actually be? Let's find another one. Josh. Where's Josh? Oh, sorry. What are the elements in A? 1, 3, 5, 7, and 9. Great. And then finally, what are the elements in B? Yue Yi. Who is Yue Yi? Yes, Yue Yi. 9, 12. Three, 6, 9. 3, 6, 9. Do you say 4? Oh, 3, 6, 9, right? Okay, so 3, 6, 9. Okay, so we only have 3, 6, 9 in our B itself. Okay. In part 2, we want to draw a Venn diagram to represent this information. So let's draw one. We notice that the elements that are in common for both A and B are 3 and 9. Okay, and the elements that are outside of A and B would actually be 2, 4, and 8. Okay. Okay. In 3 part A, we want to find out what are the elements in the set A union B bracket complement. Okay, so looking at the Venn diagram, and now that we have understood the shading idea, okay, what would the elements in A union B complement actually be? Ashley. Who is Ashley? Yes, Ashley. What are the elements in A union B bracket complement? Four and 8. Sorry, can you use your handling? 2, 4, and 8. Okay, thank you. Okay, so 2, 4, and 8. Remember to have your curly brackets as well, since this is a set. Okay, what about A intersect B prime? Rennie is that, yes. Say again. 5. 1, 5, 7. Okay, so we have A intersect with B prime. So B prime is outside, so therefore, yes, we have 1, 5, and 7. Okay, great. Venn diagrams are actually very useful in terms of classifying things as well. Okay, so looking at question 2, we want to classify triangles, the different types of triangles. Universal set to be all the triangles that we know. R is a right angle triangle, and then after that the elements in I are triangles with exactly 2 equal sides. Okay, I want to point out the idea of exactly. Okay, that means that looking at the it's really isosceles triangle. Okay, so we are given triangles C, D, E, F, and G. Okay. I would recommend that you try to draw it out to visualize how the triangles look like first, okay, before putting it into the Venn diagrams. Okay, I want you to think through this. Okay, so could I give you just 3 minutes? Okay, look at the triangles that are given and place it inside the Venn diagram that is actually drawn for you in the textbook. Well, I have drawn it on the whiteboard. I'm not giving you the complete information, so please do your own deduction.
We are all done. Are we done? Shall we look at the answer? Okay, just nice, 6 minutes up already. Okay, let's look at where should we put C. Okay, we have 8 cm, 5 cm, and 8 cm triangle. Okay, what does this triangle? What is this triangle supposed to be? Or where should I put it? I, right? Okay. Is it solely at I only, or within the intersection? I, right? Okay, because it's not a right angle triangle, so we should find that C is placed over here. Okay. What about D? D should be at I. R. Yes, should be at the intersection, right? Okay, because it is both a right angle triangle as well as isosceles. Okay, so we know that it must actually be over here. Okay, I have a question to ask about D. Okay, we want a right angle triangle and then it is also isosceles. Which are the two sides that could be that could actually be equal? Can it be possible that this and this are equal? No, right? Okay, so to be very clear about how a right angle isosceles triangle should look like. Okay. Okay, next one, E. We have a 3, 4, 5 cm triangle. Okay, so where should I put E at? Just pick out a person's name, ED. R. Okay, why do you say R? The question did not say that it's a right angle triangle, no? Sorry? Use Pythagoras theorem. Okay, so yes. 3, 4, 5, okay, you should be able to recognize by now it's a common Pythagorean triple. Okay, so 5 cm is where it is actually supposed to be a hypotenuse. So 3, 4, 5 cm will actually give a right angle triangle by using your Pythagoras theorem to prove. Okay, so therefore E is a right angle triangle. It is not isosceles at all, so E should be actually placed here. Okay. Next, we move on to F and G. F is equilateral. Okay, so just now Matthew asked me an interesting question. Equilateral has 3 equal sides. Okay, does it mean that it has exactly 2 equal sides? Okay, it doesn't, because exactly 2 means that there's only 2, but this one has a third one that is supposed to be equal. So therefore, F cannot be under the isosceles triangle portion. Okay, neither would it be right angle triangle, because equilateral triangles, can it ever be right angle? No, right? Because all the angles must be 60 degrees. So therefore, F is placed outside of the circles. Okay? And finally, we have the triangle G. Okay? 7, 10, and 12. Alright? Clearly it is not isosceles, but we may need to go and verify whether is it right angle triangle or not. Okay? So using a Pythagoras theorem, you can do a quick check that 12 square is 144. 7 square plus 10 square, that will give you 149. Okay? Because the longest side must be the hypotenuse, right? Then after that, the other two sides will be the other two sides of the triangle. So since they are not equal, this is not right angle triangle. So therefore, G must be placed outside of the two circles. Okay? Questions? Right? If not, okay, I want us to turn to our textbook. Okay, example 9. That is on page 20. By the way, are you aware that you are taking a new syllabus for your Maths O level? You are taking a new syllabus. Is it? This syllabus, you're the first one to take it for O level. You all know? Okay. So what implications are there on you? Okay. Some questions that are usually not found. That, for example, sets usually for past few years O levels, they rarely ask about description, okay, of Venn diagrams. I think that it came out once, okay, but it's not common, okay, but then now it's actually placed in your textbook. So we need to actually be prepared for it as well, okay. Let me erase this first. Some questions are quite new, not found in your 10-year series. You shouldn't actually just focus on what's in your 10-year series itself. Okay? So I like that in the textbook itself, it goes through a certain set of process, okay, in terms of describing a shaded region. We previously, earlier in, or rather at the end of yesterday's lesson, okay, we know how to shade Venn diagrams according to the notation already. So now what we want to do is that given the shading, what is the notation? How do we actually describe this shaded region? Okay. So in this work example itself, you're given these 4 different Venn diagrams, 4 different kind of shading. Okay, the process that it has given you is to ask yourself, okay, is the shaded region inside A or outside A? inside B or outside B. So it gives you this certain process that you can think through to help you figure out what notation could it be. Okay, so looking at part A, right, we see that it is shaded in A but not shaded in B. Okay, so then after that, third question it asks is the shaded region inside A and outside B, or is it inside A or outside B? There is a difference in the word and or. And means both at the same time, okay, or means either one of it. Okay, so the conclusion is that it is inside A and outside B. Inside A would mean that we have the notation A. Outside B will actually refer to the notation B complement. Okay, since it is and both occurring at the same time, the notation that we will actually refer to will be the intersection sign. Okay, so intersection sign commonly refers to the word and, okay, the logic of the word and then or will usually be the union sign. Okay, so that will actually be the answer for example 9A. Part B, okay, inside A and inside B itself, this is here. Then again we ask whether is it and or. Okay, so because it is both, okay, inside A or else inside B, right, rather than both inside A and inside B. Okay, because if inside A and inside B, then it will refer to the intersection itself. Now it is actually all the circles. Therefore, we will use the union sign. Okay, so you can go and read through this yourself. I want us to start looking at an example. So back to your worksheet. Okay, I've summarized what I was trying to refer to. Okay, a strategy that we can adopt in this case over here. Okay, whether inside or outside, and then whether is it actually intersection or union. Okay, and then after that, other additional questions that you will ask yourself. So looking at part A, right? Okay, we have these two circles and we are shading this part over here. Okay, so we are shading inside of Y, not shading the inside, not shading X at all. Okay, so that means that it is X complement, okay, intersecting with Y. Because we notice that it is outside X, inside Y. Oops, sorry. Okay. Then in this case, right, slightly more complicated. We notice that it is inside X, inside Y, but not the intersection. How could we then figure this out? Okay, so inside of X, but we don't want this part over here. Okay, so we figure out in parts. Okay, so inside of X, intersecting with the outside of Y. Correct? So if you want to figure out a notation to represent this part first, it will be inside of X and outside of Y. So this is inside X and outside Y. Okay, this will refer to this part. Okay, then right, we figure out something for this part here. So by the same logic, we are looking at something that is inside of Y, intersecting outside of X. Okay, And then now because they are shaded for both this is being shaded. So now we will tidy this up, conclude that this thing first, put brackets, and the other part, put brackets. Sorry, not intersect, what am I talking about? Union, my bad. Because it's both of it, right? It's not intersection of it all. Union. Okay? Questions for this? There are many ways that this can be expressed. Okay, so this is not the only way that you put. Okay, I can give you the other two alternatives way. Although I don't find those actually that intuitive lah. But I'll leave it for you to go and figure out. Okay, so this question over here has 3 different answers. Either what I have described, otherwise these two. Okay. Very long answer. Okay. Next, part C. Okay, how will you describe part C? I think part C is very simple. Gladys. Who's Gladys? Oh, it's Gladys. How will you describe C? Sorry? X-intercept. So X-intercept what? Okay. So Gladys says that it is X union Y prime. Can we take a look at this? Okay. So Gladys now wants to change the answer to Y prime. What do you all think? Y prime? Or X union Y prime? It should be Y prime, right? How should X union Y prime look like? X union Y prime, okay, should actually look something like this, whereby this intersection portion is being shaded as well, which effectively is your answer in E. Okay, so this one answer is Y prime, part D's answer is X union Y prime. Okay. Alright, questions? Okay. This will definitely rely on your familiarity with the shading. Okay, it takes a lot of time and effort to think through it. Okay, after you come up with something already, reverse the thinking to check whether the shading will actually be correct or not. Okay, that is a recommendation that I have. Alright, so this one I'll leave it as homework. Please go and get it done as well. Okay, for this kind of thing you really got to practice. Likewise, this one also go and do as homework. Okay, so you've got your shading. I'm quite sure shading you can finish in 5 minutes. 3 questions. Easy to shade one. Okay. And do one. Okay, then this one, definitely need to think. Alright, now let's get back to practice now 10. Okay, for convenience, I shall just use the textbook and visualizer here.
Except the last one.
Okay, let's look at this one. Okay, in the class of 38 students, it says that 11 students study physics, 20 students study chemistry, and 8 students study both. We want to find the number of students in the class who study neither physics nor chemistry. Okay, just by looking at this question itself, okay, if you try to work it inside your brain, it might not be that easy. Okay, since we already learned how to draw Venn diagrams, so let's try to illustrate it into a picture form, okay, to understand and break down the question. Okay, so we're looking at a class of 38 students, and that will represent our universal set. Okay, we have students that study physics and students that study chemistry. Let P be the student studying physics, C be the student studying chemistry. Okay? We will actually put the numbers into our Venn diagram. Not that the numbers represent the element itself. It is just for us to be able to know the values eventually. Okay? It is actually important to take note of the students that study both first, rather than to put the numbers of 11 and 20 into your Venn diagram. So the students that study both, right, that's 8 students, we place it over here. Are you able to see? Anna? Okay. Then 11 students study physics. So the total for this circle representing physics will have to be 11. We must minus away the 8, okay, such that we get 3. So therefore, there are only 3 students that study physics only and don't study chemistry. We do the same thing for those studying chemistry. 20 students study chemistry, 8 of them study both, so the remaining will be 12 students. Okay? So now with the Venn diagram, question is now asking, find the number of students in the class who study neither physics nor chemistry. Okay, I'm still missing out a piece of information actually, because in total we have 38 students. I already have 3, 8 and 12 students inside my circles. So taking 38 minus 3 minus 8 minus 12, we find that we have 15 students that are outside of the circles. Okay, so number of students who do not study chemistry and who study neither chemistry nor physics. Okay, so what this means is that it is the same idea as P union C complement. Okay, because don't study physics and chemistry one, right? So outside of P union C, okay, which is actually 15 students, which we found out by taking 38 minus 3 minus 8 minus 12 just now. So 15 is the answer. Okay. So that's for question 1. Questions? Anyone? Okay. Next we look at question 2. Okay. There are 117 participants in a conference, of whom 65 like movies and 23 like neither movies nor dramas. How many participants of the conference like dramas but not movies? Okay, again we draw our Venn diagram. Since there is a discussion about intersection, so the universal set represents the 117 students. we let M be the students, participants who like movies, and those that like dramas be D. Okay, so 65 like movies, 23 like neither movies nor drama. I can only put the 23 outside. I do not know how will the 65 actually work out, because it is this entire circle that represents 65. Oops, I'm sorry. Let me just close this up. Okay. Question is asking how many participants of the conference like dramas but not movies. That means that we are trying to figure out what is the number over here. We agree? So universal set is 117. Okay. So drawing the Venn diagram is meant to help us visualize the question. Then we know what are the steps to be taken. So, realize it might be too small for the people at the back. Okay, so how could we figure out this number? Okay, now we know that those that don't like movies and dramas is actually 23. I can find out the total number of elements for movies and drama. That will be 117 minus 23. So the number of participants who like movie and drama, or movie or drama, okay, because it's shading on both circles, that will actually be 117 minus 23, we get 94. Okay, since I know the value for both circles now, and the circle for movies is actually 65, to figure out the shading, that will actually be 94 minus away 65. So the number of D only 94 minus 65. So answer 29. Questions? Okay. Questions? All right. Now, have I copied already? Anybody still copying? Yeah. Now let's go back. Let's start with the investigation activity here in your notes. Okay, so I extracted this out from your textbook actually, so that we can actually do it in the worksheet and consolidate everything easier when you're revising. Okay, so looking at this question here, let me zoom in. Okay, it says that the universal set A and B satisfy this condition. They did not tell you what are the elements in this set itself. Okay. I'm sorry, I'm very puzzled about the conversation that is happening. Is there an issue? Am I going too fast? Going too slow? Because I noticed that counselor over there is barely writing anything. The one beside Cheyenne. While I'm seated here, I still am aware about what's everyone doing. Me choosing not to say anything earlier doesn't mean that I'm not aware. Okay. Try my best over here to convey what I need to actually say in the question. Okay, if you don't understand, then you better raise it up. Don't ask me the same question again when it's closer to your level. Okay? Unless you're telling me that you really understand you're doing something else. Because I know and I'm aware that some of you are already ahead in class. Okay, and doing something else, probably doing probability already. Okay, I'm okay with that. Okay? So now to this question. The question did not tell you the elements, they only tell you the number of elements within the set. Okay? First one, they ask you to draw Venn diagrams to show how the sets will actually be related. Okay? In your textbook, they actually gave you one of the drawing that it could look like already. So one of it is a universal set. Okay? Set A, and then after the set B, looking like this. Okay, how did they put in the numbers? It says that the number of elements in the universal set is 5. Number of elements in A is 3. Number of elements in B is 2. So actually it is possible that B is a proper subset of A. So we can have 2 over here. Then the additional 1 more out of the elements in A will be placed here. But since universal set is total of 5, we only have an addition of 3 over here, a sum of 3 over here. So therefore, there is an extra 2 that does not fall within the circles. Okay, so this is how the first diagram was being drawn in the question that's found in your textbook. Okay, we want to draw out the different possibilities that these sets will actually look like. We have already learned proper subset diagrams, okay, overlapping diagrams, as well as disjoint set diagrams. So let's look at all the different possibilities. Okay, something that we are used to is maybe looking at overlaps first. So let's take a look at that. Okay, how could we actually do this arrangement? Okay, so number of elements in A is supposed to total up to 3. Number of elements in B is supposed to be 2. If down here I put 2, right, then it doesn't make sense because I could have simplified the Venn diagram to look like this instead. Okay, because number of elements in B is supposed to be 2. I cannot have the overlap to be 2. So I'm looking at maybe the possibility of having one that is in common for both A and B. Then the number of elements in B will actually be 1 itself also, so that they add up to be 2. Likewise, okay, the number of elements in A, total will be 3. Minus away this 1, I will have 2 that is in A but not in B. And the sum of everything now is actually 4. But I should have a universal set size of 5, so I need to have 1 on the outside. Okay. And then next one, okay. So we have the subsets, the proper subset version. Okay, this is the overlapping version. And then the final version that we could consider is maybe the disjoint one. Okay, let's look at whether is it even possible in the first place. Okay, so this is the disjoint one. Okay, for disjoint is simple, we are just putting in the numbers because there's no overlaps at all. So number of elements in B will have to be 2. A will have to be 3. Okay, it is possible because total it does add up to 5. Okay, so just putting in a note over here, possible since number of elements in total is equals to 5. But it's not all the time that it's possible. Okay, why I put this note over here is because it's not all the time that this joint is possible. Sometimes if you join out like that separately, you will notice that the sum itself is more than the universal set. Then we know that it is not possible anymore. Okay, alright, I want us to stop here for this understanding. Okay, for the rest I'll complete tomorrow. Okay, so not tomorrow, sorry, next week. Okay, homework wise, okay, I know that this will definitely take you some time. Okay, shading, I know I saw some people already started doing it. That's why I say it's possible to do it in 5 minutes. Okay, I know that this will actually take some time for you to go and digest. So I'll let this deadline, okay, be on Tuesday. Would that be okay? Tuesday. Alright. So 1A, 1B, 1C due on Monday. The worksheet 1 due on Tuesday. Okay.